Where we are now is further down the main hall of the laboratory here. Behind me are other experiments. Right at the back there is one of the dark matter detectors, but as you come from there to here, there's various other projects that are here that they need to be underground in this low background radiation environment, but they're not always pure science, not always dark matter. There's very applied things we do, like atmospheric monitoring. We do some biological studies, the effect of radiation on biology. And this study we have here as well is another study that's very, very applied. These things down here are particle detectors. So they're just machines that go ping when a particle hits them. And what they're actually tuned to look for these are cosmic rays. These are the things that I told you that when we're on the surface of the Earth, you're being bombarded with all the time, that we actually come underground to get away from. It's 1,000,000 times quieter here than on the surface in terms of cosmic rays, but some still do get through. There's little blue lights flashing down here. Every time there's a flash here, one of these detectors has detected a cosmic ray. And what we're trying to do with these detectors here is see if you can use these detectors to image the rock above our heads. Because the more rock we have above us in a given location, the fewer cosmic rays will get down here, and these will go ping less often. But if we go to a part of the mine that's got less rock above our heads, there'll be more cosmic rays, more pings. So you can actually see the shadows of the rock above your heads. And there's all sorts of applications for this. Normally in big industry and in geology, you look at rock with something called seismic surveys. You make a sound, the sound goes through the earth, and it reflects off different layers. That's a very difficult technique that doesn't give good images. If, though, you can get these types of detectors below what you're trying to image, it gives you a continuous way of imaging structure that has different application to seismic surveys. Where we are now is what we call the LEC area. It stands for Large Experimental Cavern. It's a bigger space than the space where we've been through already. This space here is 6 meters wide, 6 meters high, something like 40 meters long. And this is a place where we already do some smaller scale particle physics projects. But what we hope to be doing with this in the next few years is installing much bigger projects, bigger neutrino projects, bigger dark matter search projects. One of the things we'd like to put in here is an expanded version of a project we already have down here called NEWS-G. It would be a big dark matter detector called Dark Sphere. It would be world leading. It might allow us to be the first to find dark matter. So we'd like to go there, and with other projects we'd like to put in here as well that are medium scale, too big to fit in there.